Next, we're going to look at trig ratios and their quadrants, and when certain trig ratios are positive or negative, and how that can help you find missing sides if all you're given is the ratio. So first, on your notes, go ahead and draw the four quadrants. Here is quadrant 1, 2, 3, and 4. And first what I'm going to do is just write what we know about our ordered pairs in each quadrant. So in quadrant 1, x and y are both positive. In quadrant 2, x is negative, but y is positive. In quadrant 3, x is negative and y is negative. And in quadrant 4, x is positive while y is negative. So in these, this is going to tell us a few things about it. So if the x and the y are both positive, that means that sine is positive because that's y, cosine is positive because that's x, tangent is positive because it's y divided by x, and then all of the other three ratios, cosecant, secant, and cotangent would also be positive. So in quadrant 1, all are positive, all 6 trig ratios. In quadrant 2, the y-coordinate is positive, and so that means that sine is positive, and cosecant is positive because that's the one that goes with it. Cos would be negative, secant would be negative, and then because tangent is y divided by x, that would be negative, cotangent would be negative. So here, these are the only two that are positive. Quadrant 3, they're both negative, so that means that your sine is negative, your cosine is negative, the two trig ratios that go with that are negative. However, when we do y divided by x, that means your tangent is going to be positive and your cotangent is going to be positive. And then in the last quadrant, we have our x is positive, so that means that cos is positive and secant is positive, but our sine and cosecant are going to be negative, and our tangent and cotangent are going to be negative. So this is going to give us a little clue when they give us information as to what quadrant we are talking about. So for our first example, we're going to find, and actually I'm going to go ahead and write the directions above the examples because it'll be the same for each one. So we're going to find what quadrant theta lies in. So for the first example, we have sine theta is less than 0, while cos theta is greater than 0. So they're telling us that the ratio for sine is negative, the ratio for cos is positive. So if we know that the ratio for cos is positive, then we're going to be in either quadrant 1 or quadrant 4, because those are the two times where that happens. But since sine is negative, that means we can't have quadrant 4, so this must be a quadrant 1 angle. So here we're going to say quadrant 4. Quadrant 1 was where sine was positive. Example 2. Let's say that we have cos theta is greater than 0 and tan theta is greater than 0. Here we're saying that cos is positive and tan is positive. So again, the only two places where cos is positive is quadrant 1 and quadrant 4. The only place where all of them are positive is quadrant 1. So this must be a quadrant 1 angle that we're talking about. All right, the third example of that, let's say they tell us that cos theta is less than 0, tan theta is greater than 0. So I'm going to look at, I always look at where things are positive. So tangent is positive up here and tangent is positive over here. So I'm looking for the quadrant where cos can be negative, which is going to be in quadrant 3. Now there's another type of problem we might see, and that might be if they give us actual trig ratios, or they want us to find the actual trig ratios and not just the quadrant. So find all trig ratios if sine theta equals 1/3 and cos theta is less than 0. So when I look at this, I have to think about what quadrant is sine positive and cos negative. So if I look up here, the two quadrants where sine is positive are these two. The one where cos is going to be negative is going to be quadrant 2. So this picture needs to be drawn in quadrant 2. So I'll go ahead and draw my picture. Here's quadrant 2. We're going to go ahead and label theta from the origin right there, and from the x-axis. So there's theta. I'm going to go ahead and draw my triangle. So if they gave a sine, that means that I have opposite over hypotenuse. So the opposite is 1, the hypotenuse is 3. And I'll go ahead and solve this using the Pythagorean theorem. So I have 1 squared plus x squared equals 3 squared. And I'm just using x because this is actually an x value, right? Because it's cos. So I have x squared equals, actually maybe show more work. Sorry, thinking while I write is never a good idea. 1 plus x squared equals 9. So x squared equals 8. So I'll square root both of those. X equals the square root of 8. Of course, I can't leave it like that. I have to simplify it. So x equals 2 square root 2. Now this is the part where we have to use our brains a little bit. If you look at the picture, x can be 2 square root 2, but it's a left value. It's going to the left. It's the negative x-axis. So it's actually negative 2 square root 2. That's what your value is going to be there. So if we're looking for all 6 trig ratios, I already have sine. So it was 1 over 3. So cosecant theta is going to be 3 over 1, which is just 3. Now I can go ahead and do cos theta. So adjacent over hypotenuse is negative 2 square root 2 over 3. Secant theta, we're going to have to flip that over. So 3 over negative 2 square root 2. I can't leave the square root 2 on the bottom. I've got to fix that. So I have secant theta is 3 square root 2 over 4, negative in the front. Next I'll go ahead and look for tan theta. So opposite over adjacent, 1 over negative 2 square root 2. Again, I've got to fix it. So that's going to be square root 2 over negative 4. You can put the negative in the front if you want. And then cotangent theta, I'm just going to take tangent originally and flip it upside down. So negative 2 square root 2. So I found all 6 trig ratios based off the information that I was given. Now, one more thing before we do another example. When you draw these pictures, only the x and the y values can be positive or negative. The hypotenuse is a radius, and a radius is always positive. It's just a distance from the center of the circle, basically. So when we talk about radius, the hypotenuse always positive. The x and the y are going to be the ones where the sign could possibly change on those. So we're going to do one more example of that. We're going to find all 6 trig ratios. If cos theta is 3/5, and theta is in quadrant 4. Quadrant 4. So they already told us where they want us to draw our picture. They want us to draw it down here. So there's theta in quadrant 4. I have adjacent over hypotenuse, so 3 over 5. There's my y value right there. You're probably recognizing this is a 3, 4, 5 triangle, and so the y value there is 4. But we have to be careful since this is a 4th quadrant picture. This y value is going down, so it's going to actually be negative 4. All right, so sine theta, opposite over hypotenuse, is negative 4 over 5. Cosecant theta, negative 5 over 4. We already knew what cos was, so secant is going to be 5 over 3. And then tan theta, opposite over adjacent, negative 4 over 3. Cotangent theta, I just wrote cos. Cotangent theta is negative 3 over 4.